reactive programming, web APIs, and RxJS-Web. So without further ado, let's dive into the topic. I like to talk about the RxJS docs itself. So let me start with, and I think it's already on the main page, but there it's saying RxJS is a library for composing asynchronous and event-based programs by using observable sequences. Sounds great, but if this is really the case, I was wondering okay, we have all these amazing web APIs out there for geolocation. We yesterday had a talk about Fugu APIs, which are kind of like web APIs. We have all those great APIs available. But in terms of reactivity, they kind of suck and it's very clumsy to use them. So I want to talk about this a little bit more. But let me quickly introduce myself. My name is Jan-Niklas Wortmann. I'm a consultant for Evora IT, and as already mentioned, RxJS Core Team and Angular GDE. So before we dive deeper into RxJS Web and reactive programming, let's quickly recap what web APIs are actually. So if we consider our browser as a runtime, as long as we are developing web applications, we end up with a picture kind of like that. So we have the V8 engine that is implemented by most current browsers like Chrome, the new Edge and stuff like that. And this implements the ECMAScript standard. So all the new shiny features that we like to use, like object spread and array spread and destructuring and stuff like that, all that comes with the ECMAScript standard. But on top of that, we still have our browser that can, on top of the V8 engine, provides additional web APIs. Everything that is DOM related is some kind of web API that is not part of the V8 engine, but part of the browser. And I looked up in the MDN docs to see what kind of web APIs are all available, what are all out there, what can I use in my application to make my feature set more rich and my user experience more immersive. And I figured out there are actually plenty of them out there that I never even heard of. So, for example, there's a battery API giving you status about the battery of the user's device. I never even heard of that before. So I can definitely recommend checking that out. But what I want to highlight here is that there are actually really great products out there that are entirely based on web APIs. So imagine Google Maps, for example. It's the biggest feature of Google Maps is telling you how to get from your current position to somewhere else. And all this, at least from user's perspective, that's the biggest feature from my point of view. And all this is based on the geolocation API, figuring out where you are right now. Also, Twitter is a great example for a very immersive PWA. So I'm on my phone just using the Twitter PWA, and there are so many web APIs used by this PWA. So there we have vibration API, we have geolocation API as well, we have service worker, and so on and so forth. There are plenty of features fully built upon those web APIs, providing you a similar user experience and using a native application. And when I played around for the first time with web APIs, it felt really great in the beginning. I was very surprised about all the things that are possible. But in the end, it felt kind of clumsy, and I stumbled above my own feet as I tried to compose some of the stuff. And it felt really weird sometimes to use them. And we will talk about that in some further minutes. So let me quickly tell you how web APIs are in general structured. So in most cases, we either have single value-based APIs or multiple value-based API. So for example, if we talk about geolocation, we can either get the current position. This would return a promise, returning once the value where you are right now at this very point of time. You can also watch the position, and then you're registering a callback and giving that is called every time your position changes. So to sum it up, it's usually when you have a single value that you want from that web API, it returns a promise. If you want to have multiple values, it's done by handling callbacks. And both of those approaches comes with some problems, right? So promises by default are not by default, but are always asynchronous. There's no way you can have a promise synchronous, even though this emission might be completely synchronous. On the other hand, callbacks are kind of difficult to read. When I get into programming, Callbacks were already like, oh, well, this is maybe not the best approach. We should figure out a better approach. Oh, yeah, let's do promises because they're easier to read. On top of that, both approaches are kind of difficult in terms of cancellation. It's getting better with promises and the abort controller API, but it's still not widely used. So cancellation is still... And my biggest concern about promises and callbacks is the lack of composability. So this is an example that I wrote for handling drag and drop implementation. And it is built just by using the event listener API that is also part of the web APIs, right? And here you see by passing around function references and stuff like that, binding to this context and stuff like that, requires further knowledge with that you usually as developer might not want to deal with. So my problem with all those web APIs is I'm not having a unified interface to handling all those concerns and all those approaches so that I can compose them easily. But luckily, we have observables, right? And Ben Lesh, in one of his recent blog posts, had this quote that I really like that describes RxJS really well, or observables particularly. Observables are a unified API that can represent a wide variety of things, events, multiple values, single values, and so on and so forth. And this gave me the idea, so like, okay, why not move those weird web APIs over to a more reactive approach? And what I wanted for RxJS-Web was actually not just wrapping everything in an observable and be good to go. What I wanted to provide an observable-based experience. What does that mean, for example? So when we're talking about promises by default are always eagerly evaluated, meaning even though you're not using the value, you're not calling the then function or whatever, the function is still executed, and you would, for example, register a listener to whatever. What I wanted for RxJS-Web is to provide this lazy experience that you usually get when using RxJS, meaning, for example, one of the things that I provided is it's always lazily evaluated, meaning if you don't subscribe to the observable return, nothing will happen. So maybe you're already using web APIs and you're now in the situation where you're like, oh yeah, I really want to use that. All this web APIs drive me crazy. Let's give me that RxJS stuff. So here you go. You just type in Npm Install Rxjs-Web. Do notice that it's right now in an alpha phase, but I will talk about that later on again. So what are some of the use cases that RxJS-Web can provide for you? The first one I want to talk about is actually weather, right? So the weather app is weather by nature is fully based on the information, where are you right now? I mean, I rarely look up how is the weather somewhere else. I'm looking up, okay, how's the weather right now because I'm too lazy to go outside. And therefore, it's all based on the information, where am I right at this very moment. So I have this quick geolocation example. I'm not going to show this in StackBlitz as there's a weird behavior with the geolocation API in StackBlitz and it's trolling me a lot. So you have to bear with me and stick with this sophisticated preview that I prepared here. But it's pretty much this code that handles most of the logic. And we have the from position API provided by RxJS-Web. From position creates an observable from the geolocation API, and it's calling watch position, meaning it will change every time your geolocation will change. Then we are using SwitchMap to use this geolocation information that we have and get the city by that. So this wraps an API. The code is actually fully in StackBlitz, and I will share it afterwards. So then you can see what open API I used for that. But get city by code wraps an API for my convenient usage. Lastly, I'm also rendering the city, and actually I'm doing the exact same thing, taking then the city to go to another API, getting the weather information for that city. So it's like this three steps process. First get the position, get the city for that position, get the weather for that city. This example provides actually much more already than the native geolocation API does. It supports automatic update. You can use watch position for that, but it's still callback based, so kind of tricky. It supports cancellation. it also handles the permission request under the hood. So for the geolocation API, the user can grant you access to this information, and you can also actually deny it to you. What would happen, or what does happen in normal geolocation API, you would have to call this multiple times, handle that somehow, and this feels kind of weird. This is all handled by just using from position. The example I implemented here does not support error cases. And this is not because it's not able to handle that. I'm just lazy, and it was not really important for this demonstration here. So here's also the link to the example. You can play around with it, see how I implemented everything. It's not that much code, honestly. So I also want to talk about something, and this was actually the reason why I started with RxJS-Web. I wanted to use the Mutation Observer API to build fully reactive UIs. And imagine the scenario that you're rendering elements, and for every rendered element, you want to perform an HTTP request. Meaning, you take this render information, do the HTTP request, and while it's loading, you might want to use the loading animation, and as soon as it's done, you want to implement or to show the actual data returned by your HTTP call. And often, so for example, Slack is using this kind of feature a lot, and they call it skeleton, and they have this kind of loading skeleton, and you can see this here in the example in a very easy way. So I'm rendering 3 elements, 3 times the loading screen, and then I have the text there. And the code for that is actually quite comprehensible. So let's have a quick look into that. What I'm doing here is I'm rendering a fixed amount of elements, then I'm registering my mutation observer on the parent element. In return, I want to get all the child elements. Every time something happens to the child list, I want to be notified about that. So I take out all the entries, and then I'm using sophisticated class name property to add a class to that property to trigger this kind of animation. By the way, I am so bad in CSS, so if anyone has a better approach to do with that, that was all I was able to do. So I appreciate any kind of improvement on that. But anyway, while this animation is then running, what I'm doing is I perform the AJAX call to my API to fetch the actual data. StackBlitz is under the hood using service workers, so I added synthetic delay here just to make it more visible, and then I remove the class name and render the actual content. That's all I had to do for creating those kind of skeleton animation with RxJS-Web. Let's dive into the last example that I want to show you today. Maybe, yeah. And I call this dynamic fetching. And as a consultant, I prepared a very sophisticated diagram, what I consider dynamic fetching. Meaning, first, before I do an HTTP call, I want to check the network condition. And when I have a bad network connection, I don't want the user to block his or her user experience based on this bad network connection. What I want to do rather is just load the least amount of items from a server or whatever so that the user can still interact with the app. So imagine, for example, a news app. You could do something like, okay, in case of a bad network connection, please just load the latest article. I don't care about all the others. Just load the latest article. And this way you at least save a lot of bandwidth. You still have everything for the handshakes and stuff like that, but still at least you're saving a lot of bandwidth by just returning one single item or a couple of items, however you do that. But on the other hand, if you have a good network connection, why block the user doing stuff he wants to do? So then go for it and load as many items as you want. So the code for that looks kind of like that. So we have from network, which is based on the network API on the hood, but creating an observable watching network changes. You can also use this actually if you want to implement offline-online use cases in a fully reactive manner. But therefore I had to use first or take one here to be able to not trigger multiple HTTP requests just because the network condition changed. In this case, this wouldn't make sense. What you want to do is check the network condition once and then go ahead. So I'm taking this network information and then I'm using switchmap to actually check the current network connection by target and effective type. I have still to figure out how to improve the typings for the network API. This was one of the things I noticed recently, that the typings are still not fully accurate. So bear with me that it's any right now, should be fixed in the stable version. Anyhow, I'm checking the effective type of my network connection. And if it's better, or if it's 2G or better, then I'm loading just a couple of items. If it's better than 2G, then load all of the items. For use cases like that, for sure, my server has to provide some kind of pagination API, right? But considering your server does that or your API does that, you could implement something like that. Again, Stackblitz here, you can play around with it, figure it out, and see how it behaves. Right now, RxJS-Web supports the listed items here. All the web APIs listed here are supported by RxJS-Web. And from my point of view, every web API that has a suffix observer is in some way reactive and can benefit from using RxJS-Web. So it doesn't matter if it's in the intersection observer, mutation observer, performance observer, or resize observable. All of those have valid use cases for using observables under the hood instead of promises or callbacks. Additionally, we provide observable APIs for speech recognition and speech synthesis, still a word that I'm not able to pronounce. We also have, we are going to have Bluetooth support. The pull request is open. We have support for dynamic import. So what you can do is load polyfills at runtime. And this is also one of the things that I want to mention here. We are not providing polyfills for the web APIs. So if you know you have to support Internet Explorer 6, figure out a polyfill on your own. Sorry for that. But we provide the import observables, so you can do like, okay, if one of those observable throws an error that the API is not supported, then load the polyfill and retry. And this is all possible with standard RxJS operators. On top of that, we also provide media query lists so that you can implement a dark mode in a reactive approach. I showed network and position. Under the hood, position is also using the permission API. And for sure, we expose that as well. And we have the sensor API. So if you want to do IoT kind of stuff, or like Philips Hue lights can also be controlled with the sensor API. This is your API that you might want to use for that. You might have asked, okay, why don't you support web workers? And honestly, there's already an amazing repository out there, which is much better than I could ever provide a web worker API. So if you're interested in that, check that out. They support so many great cases that I didn't even thought about before. What is missing for RxJS-Web to be released in a stable version 1.0? And honestly, the most things are tests. So if you're interested in that and want to help me with that, want to use it in a stable version, if everyone that watched this talk right now implements a test and files a pull request with that, I can release it next week. So I would appreciate it a lot. The problem is that RxJS-Web is built on web APIs, and testing native web APIs is kind of difficult, and it makes me cry a lot. I think I have an approach that I can implement good tests to provide a good release RxJS-Web stable with confidence, but there's still lots of tests missing that I want to have before releasing RxJS-Web in a stable version. I want to use this moment as well to thanks a lot to all the contributors that helped me a lot already and are still helping me with filing pull requests, adding new features and stuff like that. Thanks a lot to those amazing folks. Last thing before I wrap up my talk is I want to highlight why RxJS-Web is not part of RxJS Core. So there are actually 2 points that come into that. The first one is that we are in RxJS trying to limit the API surface. We're rather prefer having new operators in user-landed libraries so that we can verify the usage, how well is it received by the community and stuff like that before we consider moving that to RxJS Core. Just because as soon as we have it in RxJS Core, it's a commitment that we will take care of the maintenance of that. And the other thing, RxJS-Web is clearly just supporting web APIs and therefore not running in a node-based environment. RxJS, on the other hand, aims to be fully compatible and be able to be used in Node.js applications. So those are the 2 points that come into play here. Anyway, that's all I got. I hope you enjoyed hearing about RxJS-Web. If so, I would appreciate if you approach me with ideas, feature requests, and stuff like that. I'm very happy to chat about that. And I will also be around for the Q&A. So if you have any further questions about that, feel free to drop them in the Q&A. Thank you.